Welcome to another episode of Investigation. In today's episode, I'm going over the first 10 problems from the most recent AMC 10 set. So let's get started with AMC 10B number 1. The first problem asks how many integer values of x satisfy this. We know that pi is around 3.14, therefore 3 pi is around 9.42-ish. It asks what positive integer values of the absolute value of x is less than 9.42. We know that the biggest integer less than 9.42 would be 9, and remember to add an equal sign here. So x, the absolute value of x is less than or equal to 9. We can just list them, or we can do a casework. -9 to -1 would be one of the options. 0 would be one of the options. Let me write it more clear. -9 to -1, 0, and 1 to 9. In this case, it will be 9 options, this is 1 option, and this would be 9 options. In total, there will be 9 plus 1 plus 9, or 19 options, giving us the answer choice D. So let's proceed with number 2. In number 2, it asks that this expression squared to the square root. Any number squared would be a positive number, or at least non-negative number. It can be 0, but any number squared takes the square root is also a positive number. So we need to be careful when we extract this, when we unpack this, to make it a positive number at the end. So let's get started. 3 minus 2 root 3 would be less than 0, which we don't want. So what it actually is this 3 minus 2 root 3, the squared and square rooted would just be an absolute value, plus the square root of 3 plus 2 root 3. This side would give us 2 root 3 minus 3. This side would give us 3 plus 2 root 3. The 3's cancel out, leaving us the answer 4 root 3, or answer choice D. So in number 3, in an after-school program for juniors and seniors, so we know that there are juniors, there are seniors, there is a debate team with equal number of distance from each class. This each class just means each junior and senior. It doesn't mean like each class inside junior or senior. It just means junior, senior are both one class. Among the 28 students in the program, in the after-school program, not in the debate team, 25% of the juniors and 10% of the seniors are on the debate team, meaning that 25% of the juniors and 10% of the seniors are on the debate team. And we have another equation where juniors plus seniors is equal to 28. So if we simplify this, this will be 1/4 junior is equal to 1/10 senior. And it asks how many juniors, so we need to get rid of seniors. So that's 5/2 juniors is equal to seniors. Getting back to this equation, we can see that 5/2 juniors plus juniors is equal to 28, and 7/2 juniors is 28, so juniors would be 8, giving us the answer choice C. Moving right along to number 4. So in number 4, 57 students and 75 students are each wearing blue and yellow shirts in the total of 132, meaning there are no students wearing like red shirts. So they're assigned into 66 pairs. Out of those, 23 times 2 or 46 students are wearing blue, meaning that the rest 57 minus 57 minus 46 or 11 students are assigned in one blue and one yellow teams. And the rest teams must have 2 yellow members, meaning that there are 66 minus 23 minus 11 or 43 minus 11 or 32 teams that are both members are yellow, giving us the answer choice B. Alright, we're up to problem number 5. The ages of Johnny's 4 cousins are single-digit positive integers. So one of them is 24, one of them 30. 24 can be equal to 3 times 8 or 4 times 6. We can't decide on that. 30 is equal to 3 times 10 or 5 times 6. However, since they're single-digit positive integers, 3 times 10 is not valid. The only choice would be 5 times 6. And 6 already used, and it has to be distinct, meaning this cannot be a possibility. So the other two would have ages of 3 and 8. The sum would be 3 plus 8 plus 5 plus 6, or 22, giving us the answer choice B. Let's go on to number 6. This is also actually a problem from 12B number 4. So if you're from 12B, you can watch this problem as well. So the most important information, at least I think, from this problem would be the ratio or 3/4 ratio. What I did was to assume that the morning class has 3 people and the afternoon class have 4 people, and they have a mean score of 70. The morning class would have the mean score of 84. To find the mean score of that, we just simply need to do 3 times 84 plus 4 times 70 all over 7. That is fairly easy, and I will take you through the calculation. 3, 4 is 12, 250, 280, 7. We see that we don't, I will just finish that for now. So that's 532 divided by 7, or 7, that's 49, 42, 76, giving us the answer choice C. But we realize we don't need to calculate it like this because there is an easier way to do so. On this step, we see that 84 and 70 are multiples of 7. So we just need to do 3 times 84 over 7 plus 4 times 70 over 7, or 3 times 12 plus 4 times 10, or that's 36 plus 40, or 76. It is much simpler than this solution and gives the same answer. So let's proceed with number 7. It states that in a plane, 4 circles are tangent to that one line. And if I can draw a little bit, we know that in order to save, we have 2 sides. In order to save the most area, the biggest 2 circles have to be on the opposite sides. And the smaller ones, by natural, some may think that it would be better to have one on each side. But that is not the case, because that would actually reduce the area. If I have that 1, 3, 5, 7, that will give us 49 plus 25 minus 9 minus 1 pi, which is equal to 64 pi. We can add the area by a little bit by moving that 1 to the other side, so that that 5 squared doesn't have to subtract by that 1 anymore. That is where my diagram comes in. 1, 3, 5, 7. And that will bring us to the area of 49 plus 25 minus 9. And we don't need to minus 1 anymore. Pi, or 65 pi. Slightly more than the previous one, but it is more, giving us the answer D. So let's proceed with number 8. In number 8, you will realize a pattern on the top right of each loop. If I define this as a loop, on the top right of each loop, it is a square number. Not too surprised, the most top right would be 225, or the last number in this grid. So we want the second row, so here it would be 13 squared, or 169. This would be the 14th number of the second row. We want the second number of the second row because the first number will proceed to the first row. The second number would be 169 minus, that would be 12 apart, or 157. And the first number, if we calculate the first number and the first row, we would come up, and minus 1, we would come up with the first number on the second row. So now we just need to find this number. This number can be directly get from 225. That's the 15th number. That is the first number. So this number would be 225 minus 14, or 211. So this number, or the greatest number on the second row, would be 211 minus 1, or 210. Our answer would be 210 plus 157, or 367, giving us the answer choice A. Let's proceed with number 9. This problem is actually a problem from 12B set, or number 5 from it. In this problem, it states that the point P after the transformations is at -6, 3. We can use reverse logic to get back to the point P. So let's get started. First of all, the ending point, -6 or 3, should be here. And it is reflected of y is equal to -x. Of course, this can be extended to the other side, but we don't really care about it. And after the reflection, or before the reflection, the point would be at -3. The point would be at -3, 6. Now, this point is actually rotated 90 degrees counterclockwise. We want to rotate it back, and it's around the point 1,5. Let's use that 1,5 here. 1,5. This is not drawn to scale, so don't take that very seriously. And let's draw that. And 90 degrees would be about that. And we realize that this would be 1, this would be 4. That is a 1-4 triangle. Therefore, after rotating 90 degrees, this would be 4, this would be 1 away from 1,5. And the final coordinate would be 2, 9. It asks what is B minus A, So our answer would be 9 minus 2, or 7, giving us the final answer 7. This is the last problem that I will go over today, or AMC 10B number 10. This is also from AMC 12B set, or number 6 of it. And it states that an inverted cone, just like this, whose radius of 12 centimeters and a height of 18 centimeters, with this being the right angle, is full of water. So let's calculate the volume of it first. The volume would be 1/3 base area pi r squared, or pi times 12 squared times the height, 18, which is equal to 6 times 12 squared pi. We can leave it here because we know that we have to divide it out eventually. And let's draw the big cylinder. So the cylinder has a much bigger base, or 24 centimeters. The base area base, is equal to pi r squared, pi times 24 squared. We know that the volume inside the cylinder would be pi 24 squared times h. And these two volumes are the same because they're the same amount of water. Therefore, 6 times 12 squared pi is equal to pi times 24 squared h. And if we cancel out some of these, that will be 4 pi h is equal to 6 pi. And cancel that out, h would equal to 6 over 4, or 1.5, giving us the answer choice A.